What's up, rock stars? Hope everyone's doing good today. Today we have an important topic to talk about, and that is two-step linear equations. We're going to be solving these bad boys. I have a one-step linear equation. I have a modeling two-step linear equations. I got all the videos about equations. Get out there and watch them if you haven't. All right. Let's see. Why did the horse keep falling over? It just wasn't stable. Horse stable. Okay, so today we're going to apply properties of real numbers and properties of equality to solve two-step linear equations in one variable. Okay, that's the goal today. Okay, so lock in. Lock in. This is super easy, but also I want you to really pay attention how I'm showing my work on these slides so that you can see how you're going to be showing work when you do your assignments or your tasks or live in the real world, whatever it is. Okay, remember, equations are like a balance. You've seen this before. Okay, the equal sign is the balance point. What happens on one side has to be the same thing as what happens on the other side. So what we're going to do is we're really going to be focused on understanding that anything that happens over here, we have to do it over here, okay? Because otherwise the balance becomes unbalanced, and that becomes unequal, and that becomes a way that I'm sitting on the balance and I go to the ground and people fly off the others. Okay, I'm going too far. All right, solving two-step linear equations. These are the basics. What is the big goal? We need to get that variable by itself. Okay, the whole goal is at the end of this equation, we have the variable equals something. And the variable could be j equals something or something equals s. We want to make that variable so lonely that he cries himself to sleep. Get him by himself. The second thing is we're going to be simplifying expressions or simplifying equations using the flippity-flip GEMDAs. So when we're solving expressions, we use GEMDAs. When we use equations, we flip that bad boy over and use GEMDAs backwards, okay? So we're going to start at the bottom and work our way up. Flippity-flip. Okay, third, reminder that when I use inverse operations on one side, I must do the same on the other side so that my balance stays balanced. I can't put a buffalo on one side and nothing on the other side, or that buffalo is going to knock the whole balance over. So in other words, what I do on one side, I must also do on the other side. Okay, so let's solve some equations. Now I put the keys up there. Get the variable by itself. Reversed GEMDAs, okay? And then inverse all operations to get the variable by itself. Those are the three things we're going to focus on, okay? So here's our equation. And we're going to reverse GEMDAs to get there. So our goal is to get the get the variable by itself. So step one, reverse GEMDAs. Do you see any addition or subtraction? And yes, you do. You see 2x minus 8. So we're going to do the inverse of minus 8, which is we're going to add 8. Okay, so this is step one. Remember, these are two-step equations. And if I add 8 to one side, what do I have to do? I have to add it to the other side. And let's go ahead and solve each one of those. So negative 8 plus 8 equals 0. Those are 0 pairs, right? And 10 plus 8 equals 18. And then all you do is if I was on a piece of paper, I would literally draw an arrow, and then I would bring that 2x in the equal side down so that we could work on the next step. That's why these are called two-step equations. I learn something every day. So step 2 is, do you see any multiplication or division? Remember, we are using GEMDAs backwards. And the answer is yes, we have 2 times x. So step 2 says, do the inverse of multiplication. What's the inverse? So it's 2 times x or x times 2. Let's divide by 2. We're trying to get rid of the coefficient here, so we're going to divide by 2 using the inverse operation. And what I do to one side, I have to do to the other side. Okay, so when you divide 2 divided by 2, you're going to get 1. And so the reason why you can cancel that out is because you're basically saying 1x. And if I have 1x, I just have x, right? All right, and then the other side, you're going to say 18 divided by 2 is 9. So 18 divided by 2 is 9. We've gotten rid of the 2 divided by 2, so now we have x by itself, and our answer is 9. That's it. That's all you do. One step, addition, subtraction, inverse it, do the math. Step 2, multiplication, division, inverse it, do the math. And we've got the variable by itself. Let's try another one. All right, so let's say we have negative 2x plus 8 equals 10. Okay, so I just changed some signs around so that you guys could get a look at this. So remember, we're going to do GEMDAs backwards, and our goal is to get that x by itself. All right, so step 1, do you see any addition or subtraction? Yes, we have plus 8. So we have to do the inverse of that. Okay, what is the inverse of plus 8? Minus 8. Okay, and what I do to one side, I have to do to the other side. All right, so plus 8 minus 8 is going to give us a cancellation. Those are 0 pairs. And on the other side, we're going to say 10 minus 8 equals 2. Bring everything else back down. So we have negative 2x, and we also bring that equal sign down. And we're going to go to step 2, which is, do you see any multiplication or division? Absolutely I do. And the reason I did this problem is because I wanted you to see that it is still multiplication. So we're going to do division, but we're going to divide by the negative 2. So you have to divide by whatever the coefficient's value was next to the x, okay? It was a negative 2, so we're going to divide by negative 2. And what I do to one side, I must also do to the other side. So negative 2 divided by negative 2 equals a positive 1. So we can cancel that out because positive 1x is the same thing as just x. And then 2 divided by negative 2 is going to equal a negative 1 because a positive divided by a negative is going to be a negative. And then since I've canceled out this, and I've also canceled out my negatives, right, because it became a positive 1, I just bring my x and my equal sign down, and I am done. Wow. One more. This one's a little bit harder, okay? What if it looks like this? So how would I read this? I would say x divided by 3 plus 4 equals 7. Nothing changes here. Nothing changes at all. So, inverse. I have an addition problem. I have plus 4. So we're going to do the opposite of that, and we are going to subtract 4. What I do to one side, I must do to the other side. These right here are 0 pairs, so they cancel out. We don't need them anymore. 7 minus 4 equals 3. Wow, you wrote that a long way down there, Tal. Why'd you do that? Well, because I'm bringing down this big old fraction, so I needed some space for it. So I just bring it down with the equal sign. And now step 2 tells us, do you have any multiplication or division? And yes, this is x divided by 3. Remember that fraction bar also means divided by. So what's the inverse of divided by 3? Well, that would be multiplied by 3, okay? And so we're going to multiply by 3. And 3 over 1 is the same thing, right, as 3. And then what I do to one side, I have to do to the other. So why does this cancel out? Well, if you multiplied across here, you would get 3x over 3. And what's 3 divided by 3? That's 1. And what is 1x? That is 1. And that is just x. So it just cancels itself out. So when you do this by the inverse, you can just automatically cancel everything out and bring down your x. And what is 3 times 3 over 1? Well, 3 times 3, this is the same thing as 3 over 1. 3 times 3 equals 9. 1 times 1 equals, 1 times 1 equals 1. What is 9 over 1 equal to? It's the same thing as 9. We've canceled out the other side, so we just bring down that x equals. And once again, we have gotten the variable by itself. That's it. First step, add and subtract, right? Do the inverse. Second step, multiply and divide. So what's the goal of an equation? Well, we're going to get that variable by himself. Get him lonely, my friends. Step 2, what is that thing we do backwards? It's the moonwalk, but it's also GEMDAs. GEMDAs. And number 3, whatever I do on one side of the equation, I do to both sides. That's huge, okay? And then the inverse operations gets us out of that. So you add and subtract first, do the inverse. That's step 1. Add and subtract, or so if we do that first, and that's the second step is multiply and divide, do the inverse. All right. Let's see. What do you get if you mix a rabbit and a snake? A jump rope. Rabbits jump and the snake is the rope.